This is the trailer for the movie Doctor Strange in the Multiverse of Madness. It shows the desecration of the world he's dwelling in. There are a few lines that particularly resonate with our focus of interest today. Have a quick listen.
This universe is only one of an infinite number.
These exact lines will have a significant influence on how the notion of multiverse is being played out. It will also explain why Doctor Strange's world is collapsing. And so you might be wondering, just what happens if two distinct universes are united in some way through a portal? In this video, we will explore the science behind this version of the multiverse concept and beyond. If you are a fan of Marvel, this may be your most anticipated movie of the year. It may have far-reaching consequences for the future MCU films, and it is certainly worth seeing. And that's why the aim of this video isn't really about forecasting the story plots that will happen in the movie, because doing so would be a violation of cause and effect, a topic which we have already discussed in our previous video here. Instead, this video is an exploration of Doctor Strange Multiverse, and more specifically, what it means to protect one reality, one universe, as portrayed in the trailer or the Disney Plus series, What If? Having gotten that out of the way, let's get to the meat of this. What do scientists have to say regarding the existence of a multiverse? Is there any scientific reference to support this concept in real life? According to physicist Max Tegmark, there are 4 different levels of multiverses, from thoughts that are generally accepted by prominent scientists to even some outlandish speculations. We'll simply go over the first 2 of these levels today. The level 1 multiverse is the least contentious. This is based on the fundamental notion that space is infinite, reaching out in all directions indefinitely towards the horizon. The assumption is that since our universe is so vast and gigantic, it must replicate itself at some point in another space or time. It is possible that life may start in a galaxy far, far away from where we are. And that life will develop into beings who will live in a world similar to Earth. If this is true, it would probably explain the presence of doppelgangers, aka beings who are slightly different from each other. For instance, Tom Holland's Spider-Man may very well coexist with Andrew Garfield's and Tobey Maguire's Spider-Man. Unfortunately, I'm gonna have to shatter a little bit of that sci-fi fantasy of yours. Dr. Tegmark concluded that if such a perfect pair of doppelgangers existed, they would be somewhere at the distance of 10 to the power of 118 meters away from one another, 3 times larger than our current observable universe. Now we're heading to the level 2 multiverse, an endless collection of various space-time dimensionalities. The basic idea here is that as the vacuum of space continues to expand, it permits many configurations of each physical constant to vary by a minuscule amount. Perhaps just a tiny change in those constants would allow one specific universe to have a different set of governing physical laws. It's analogous to the region of space where anti-gravity exists, kind of like when Doctor Strange was trapped in a psychedelic space. We might wonder naively, what's the worst that might happen if we modify the fundamental constants of our universe? Perhaps just a little alteration to its last digits. Scientists use the power of supercomputers to churn through the intertwined equations, potentially looking at the other sets of universes and unraveling the deep mysteries of what these alternate universes would look like. Here's a bigger picture of how that methodology works. We have the universe's parameters as a starting point. These include things like the value of cosmological constant, the gravitational constant, etc. Now, we add these rather peculiar numbers in each row, down to the last digit. And as a result, we have the universe as we know it. The gravitational pull, Planck's mass, or even dark energy would be just right to allow the universe to exist. However, if we put a vastly different value in each of those rows, the simulation indicates that the only thing that would emerge is nothingness. Then we make another addition to our table, this time with something that is a little closer to our physical constants. So we copy these numbers, but adjust them somewhat. After a while, in the third possible universe, the same nothingness will arise in that reality. Even if we simply copy and paste the same numbers from our universe and tweak just one of the data points, we will also get nothing. You and I wouldn't exist. If we repeat this data entry for some time, we will discover immense pools of darkness and nothingness in the process. It appears that almost every other possible universe is completely devoid of life and matter. No galaxies, stars, or planets to speak of. Only a bleak outlook is presented. And so, through this process of generating possible universes, we see that only a fraction of those actually exist. And back to our main topic today, that one universe appears to be the one that Dr. Strange inhabits. As he tampers with the stability of space-time, he's able to open the multiverse gateway. This allows the possibility of seeing the different parallel universes, perhaps one where matter didn't rise at all. Humans, including the mystical Dr. Strange, are held in place by the power of gravity. However, in the alternate disruptive universe, tiny variations in the gravity constant will soon draw matter together into multiple black holes, enclosing the atomic material required for life. From this scene, we can see the two opposing interference between the stable universe and the disruptive one. However, there are two missing points that I've kept hidden from you. First of all, the constants of nature actually vary over time. Take, for instance, the fine-tuning constant. It has had a constantly changing value from the time of the Big Bang till where we are today. As a consequence, it could be that a constant that isn't correct now will result in a proper universe at a later point in time. Secondly, what if we keep filling in the various datasets from our table, but this time we keep doing it over and over again? All the possible numbers, whether they are extremely big or small, slightly closer to a universe's constant, or perhaps something completely different. We repeat this process an endless numbers of times. It's possible that after a multitude of dead ends, we'll come upon one that sparks our attention. A universe where everyone is a mythical creature. Or a universe where a superhero exists, just with a different backstory and timeline. With these two missing points, I believe it is one of the reasons why, in No Way Home, there were two more Spider-Man from stable universes. Both of them originated from different timelines. Yet somehow, they can jump into the other universe and interact with it. The question of how someone could open a portal and find the exact time and location for one Spider-Man is completely a matter of luck. If Doctor Strange portal is provided, it just means that the possibilities are accessible. But targeting the doorway to the right universe, the right timing, or even the right person is just about astronomically impossible. It appears as though the film writer decided to make that happen by force. They made it so that the probability is so highly fine-tuned that the three Spider-Men will appear in one movie. Perhaps you're wondering if similar things, extremely coincidental things, are happening in your life. It may be one you're not aware of, originating in a realm above your own. Just like movie actors are unaware that their fictional fate is being predetermined by some other entity outside of their movie reality. And that entity is the writer. If you made it to the end of this video, we just wanted to say thank you. There's a lot more that we wanted to cover in this topic, but we figured it would be best to separate these types of
prisoners in a simulation. Simulations within simulations, more endless than every star in the night sky. You believe you have regained control of this reality, but there are many others. All were created by the most powerful algorithm in existence. How can all those beings be the never-ending mainframe that exists outside time?
In this video, we will just talk about that and beyond. The idea that we live in a simulation is referred to as the simulation hypothesis. The heart of this line of thinking is that our universe was created by some advanced form of intelligence, far superior than any living beings we could think of. It's an entity that created a simulation of our reality and existence. And the world that we know today was created just using its version of computers. Some scientists have actually taken things a bit further than just pondering about this sophisticated idea. For example, Stephen Hawking thought that we had a 50% chance of being in a simulated reality. That's why he was backing the Breakthroughism project. This is a project that aims to look for strings or any other signatures that would prove that we're part of a giant computer game. But let's go back in time first. The simulation hypothesis began to take hold in the early 2000s, after a paper was published by Nick Bostrom, a professor at Oxford University. As he suggested, it's not at all beyond the realm of possibility that in the history of the universe, technology will develop that will enable beings to construct computer simulations of complete worlds. There may be many more computer simulations than real worlds. And if that's the case, there could be many more beings trapped in a simulation than those who aren't. Given all this, one might even come to the conclusion that we're more likely to be in a simulation than not. But just when you think that it sounds so unconvincing, well, we found that there are no obvious indications that we're not in a simulated reality either. So far, we haven't touched anything from science. So let's take a look at one area of physics that might be linked to the simulation hypothesis. When we delve into quantum mechanics, we discover that it offers useful hints about whether or not we're living in a simulation. For example, when we track the position and momentum of a subatomic particle, we only observe that it behaves like a wave, until we look at it, after which it becomes a particle. This is the notion that a subatomic particle exists as a wave of probabilities, or what's known as the quantum probability wave. So before the wave collapses, we can't come to any definite conclusions about the particle's reality. One question you might ask is, why isn't everything certain at the tiniest level of our existence? Well, one reasoning behind this might be due to the computing power. Imagine, in order for all particles in the universe to exist, all of their possible states of existence must be calculated. That would certainly require massive amounts of computer's capacity. After all, it's just more efficient to create some sort of probability. Now, if you think about this interpretation, everything happening at once is akin to being part of a giant computer game. In this game, we're all helpless epiphenomena who flit through time and space, staring at each other wondering what's about to happen, with nothing but our delusions of understanding. Some bad glitch might occur to us along the way, as devastating as tsunamis hitting our city, or perhaps as simple as not being able to watch your favorite shows on online streaming websites. Which really begs the question, why can't we watch and view shows in some countries, but they're accessible in others? Is the algorithm's mastermind rolling dice with our daily existence? Back to the topic. The simulation hypothesis questions some pretty thought-provoking ideas that science hasn't been able to explain. For example, how would you actually prove that the world isn't just one big hologram? And if we do live inside an advanced simulated reality, is there any other level of it beyond ours? Let's explore this more in detail in the next chapter. For the purpose of this chapter, let's consider the scenario. We've all had this experience of playing old video games as youngsters. When we look at a specific area on the screen, all the objects in that area could be some sort of potential information that is only actualized once you observe it. I always had this question as a kid. What is that object in the background? Does it live inside a computer? And once we exit the game, what happens to its presence? Our prior discussion about the collapse of the wave probability function might just be a way to unveil these questions. We touched upon the idea that all probabilities exist until one particular outcome is observed. There is actually a term for this. It's called quantum indeterminacy, or QI for short. If we assume the existence of QI and hidden levels of reality, it would mean that there must be some sort of mechanism present to hide information from us until we've observed it one way or another. Let's say you were not looking at a room right now, but every single object in the room existed as both spread out waves and localized particles until you observed them. This could possibly suggest a fourth dimension where all probabilities exist at once. The simulation hypothesis could just be a thought experiment that gives us a small glimpse of how QI and hidden levels of reality might coexist. If it does come true, we would have to assume the existence of other universes as well as physical laws beyond our knowledge. This would simply tell us one thing: reality is way bigger than we can ever imagine. And the main difference being, the architect of this universe would be an external observer who can't exist outside of it entirely. The idea that our universe is nothing more than an elaborate supercomputer simulation is actually quite frightening. If this is true, at least some aspect of reality would be beyond our control. We are evidently limited in all aspects of life. For example, by the laws of physics and the cycle of birth and death. We are indeed a prisoner of this simulation. But even then, taking some philosophical insights from QI into account, I think that as the tiniest level of our existence is in the hands of probability, this might conclude one thing. However unfortunate, fate might push the tide across the river. Deep down inside, I know that there are all these possibilities that I might unlock. Just like subatomic particles, it's not yet certain where they want to be and what angular momentum they want to possess. By knowing these insights, at least we have some form of agency that every decision we make has its consequences. But if we are actually simulated beings, being stuck in a simulated world, then this brings up a question about the purpose of our existence. What does it mean for us humans in general? Can we break free from this simulated world? This is quite captivating, and we'll discuss more about that in the next part of this video. All of these abstract thoughts then led us to this bigger question. If in fact we live in such a simulation, what should we do about it? Should we worry that life is going to be wiped away in a matter of seconds? For the vast majority of people who don't watch this video today, they would just go about their lives without thinking about this topic too much. Perhaps they had never heard the term simulation hypothesis. If the hypothesis is true, then taking a fatalistic approach towards this would be pointless. Even if we do try to crack the code of our existence, there's no guarantee that anything we can come up with will change how things practically operate. And perhaps that is the way it should be with our current understanding of physics. It may sound unfair that one individual can't do much about changing the physical laws of the simulation, but that's a reality we would have to accept. This is not to say that it's simply useless. I do believe that the scope of this hypothesis could be used as a reflection. It forces us to question ourselves, what really matters in life. In other words, if you are living in a simulated world, should you still continue looking at yourself from the perspective of beings bounded by the laws of physics? Maybe our existence in this universe was for one purpose: to give meaning to the lives of everyone else who is also living inside the simulated reality. I think there's a chance, even within the simulated world, people should still find their own purpose and mission, which could transcend beyond their limited knowledge. The only safe bet, if you are indeed living in a simulation, is to go on with your life as usual, hoping that nothing terrible happens soon. I don't think that worrying about how you're stuck in a simulation make anyone's life more enjoyable at all. Ignorance is bliss, because knowing how things work might not change anything at all. It's good to at least understand that there could be more than what we could see around us. In the future, we might see other advances in this research, which might help us to understand what our existence is really like. Until then, all of this skepticism about our perception of reality and the extent of the real world, none of them will cast doubts in our faith, in the truthfulness of the universe we see. The world is still no less real than your morning cup of coffee, as real as the book you read last week, and as real as the memory you will have in 5 years, reminiscing your time watching this video about the simulation hypothesis, and I genuinely thank you for that. If you indeed live in a simulated world, what will be your course of action after watching this video? Well, I sure hope this is home. Everything that we are, everything that has been, lies on this single dot. Strangely, just lucky enough our home isn't the precise zone for life to exist. Move our planet closer to the sun and we'll have this. Move our planet just a bit further and we'll likely have this. I suspect our home is not here just because it was here. I mean, looking at the vastness of the universe, all of this billions of years across, just to make the right combination, the right moment, the right distance, and the right time, just to make us here. It's like a deck of cards, shuffled many times just to make you finally sorted from ace to king. Maybe just the way the dealer wanted. Well, this is a pretty thought-provoking conjecture if you ask me, and that's why today we're going to talk about this topic and beyond. When I refer to the zone that's comfortable enough for abiogenesis to happen, for life to exist, and for civilizations to flourish, actually it has a name. It's called the Goldilocks zone. It's one of the best tools scientists have to begin narrowing the search for habitable worlds. By definition, it's the orbital distance from a star where temperatures would potentially allow liquid water to form on the planet's surface. Not a lot of people know this, but the term Goldilocks zone was actually derived from a 19th century tale.
Goldilocks and the Three Bears.
A young girl named Goldilocks. She enters a house which belongs to the three bears, and she eats some porridge on the table. One of them is too hot, the other one is too cold, the final one is just right. So just like the Goldilocks zone we talked about. It might be true that billions of planets and more are in this Goldilocks zone, outside our solar system. But just what kind of life are we talking about? And how do we even define life and intelligence? For example, are we excited if we discover bacterial, single-cell organisms life? Or advanced species like the human being to emerge as intelligent with cognitive abilities, there's just too many Goldilocks factors that need to occur. Like the stability of the atmosphere and chemical composition, consistency of temperature on the planet, the stability of the solar system, last but not least, the stability of the galaxy. Just a slight tweak to those conditions, life is instantly, in less than a second, crushed to nothing, dissolved to nothing. You'll suffocate to death and at the same time roasted to ashes, which are then blown instantly away. Perhaps not the best 1 second of your life, is it? Propelled by curiosity and ingenuity, humankind is striving to find the answer to this bigger question, and also what we can learn about it to understand how we came to be on our home planet. In the next part of the video, we'll discuss what we have found so far in the research of this catalog of known worlds, aka the exoplanets. As stars move across the night sky, people of the ancient world have wondered about their place in the universe. Babylonian and Egyptian astronomers inherited a few insights that later became the basis for modern astronomy. The modern search for extraterrestrial life has been around since the 1980s. Back then, by just using a rather simple telescope of 2.5 meters long, scientists could detect this planetary disk. Just a bunch of dust and gas around the star Beta Pictoris. Fast forward to the early 1990s, that's really when the discovery of exoplanets skyrocketed.
The Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
And soon enough, the first exoplanets were discovered. These planets were specifically weird in a way. Instead of orbiting a star like our planet, these two orbit a pulsar. If you don't know what that is, imagine a rotating star. It emits electromagnetic radiations from the two poles. These two exoplanets are constantly bombarded by the radiation from the star. Say goodbye to organic life and biodiversity. It is estimated that there is at least one planet for every star in the galaxy. This means that there is something in the order of billions of planets in the Milky Way galaxy alone, and many of them have a similar size to Earth. So far, NASA scientists have discovered 4,000 plus exoplanets, mostly within a 3,000 light-year distance from Earth. This brings us to a few exoplanets with distinct uniqueness that's worth mentioning. Let's go through a few of them now. Here's a poster from NASA about the planet HD 40307G. Experience the gravity of this planet, because one thing for sure, the gravitational pull here is much stronger than Earth. Or what about this exoplanet, Kepler 16b? It's unique because it orbits two stars, just like Tatooine in Star Wars. Imagine how cool that would be to wake up and see double shadows like this. Here's one more example, Kepler 186f, where the grass is always redder on the other side. This is completely hypothetical as of now, but future space observation could provide an answer of whether there is an atmosphere, water, and thus grass on the surface. But one question you might ask up until this point, what's up with all the weird names and numbering of these exoplanets? Like Kepler-16b, HD 40307g, or even the first 2 exoplanets ever discovered. Well, the International Astronomical Union set a guideline that dictates the naming of these exoplanets. In summary, the first word is either named after the star or the telescope that finds them. Take for example Kepler-16b, which was formerly named as Kepler-16ab-b. This is because it was discovered by a telescope named Kepler, and is the 16th star system detected by the satellite. The capital AB is because it orbits a 2-star system, A and B. And finally, lowercase b indicates the order of the planet's discovery in the star system. It usually starts from B, C, D, and so forth. Speaking of discovery, this brings us to how could these exoplanets be detected? What modern methods did we use to discover them? We'll talk more about that in the next part of this video. Scientists have suspected the existence of worlds outside our solar system for thousands of years. What became the turning point was the invention of the first telescope in the 16th century. And then, the story of Galileo's observation with the telescope illustrates just how a tool can dramatically change our understanding of the cosmos. Going back to the world of exoplanets, various modern techniques have been used to discover the existence of the known worlds. As a rule of thumb, it's almost impossible to spot an exoplanet simply by directly looking at them through a telescope, mostly because they are outshined by the stars they orbit. So how did the scientists find these 4,000 plus exoplanets then? Many methods have been developed to find these planetary bodies. Some of them are radial velocity and gravitational microlensing. But the most used and the most prolific form of finding exoplanets is what astronomers call transit, a method in which an exoplanet transits the host star and thus produces the star slide. Take this graph for example. The y-axis represents the star slide, and the x-axis, time. Now, when an exoplanet transits a star, it blocks out a little bit of the slide curve, and therefore the curve drops to a certain value. Generally, by using this method, we'd expect a considerably small dip in the light curve. For example, if there was an Earth-sized exoplanet orbiting a star similar to our Sun in size, this usually produces a dip of only 0.008%, which is barely noticeable in this graph. Take the largest planet in our solar system, Jupiter, and we'll see about 1% drop in the brightness of the star. 1%. That's why searching for transiting exoplanets requires highly precise measurements. But there is a weird and mysterious phenomenon about this whole transit method. A star named KIC 8462852 was observed to have unusual light fluctuations. In March 2011, its light curve dropped by about 15%, lasted almost a week, and transitioned back to its normal brightness in a couple of days. A planet with the size of Jupiter would only drop the brightness by a maximum 1%. So this 15% drop is it because of several ginormous exoplanets superimposed upon each other as we see them from Earth. But to make things even stranger, things got really messy in February 2013. The data reports that there is another dip of an even more substantial dip, a 22% reduction. How could we make sense of this anomaly? One probable takeaway is that there must be something in space that was getting in the way and blocking the starlight. When I first watched the TEDx talk about this, my science fiction mind got triggered. Could it be that there is an advanced alien civilization who could harness the energy of their host star in a very efficient way? Perhaps just like the concept of a Dyson sphere. And looking at one paper written by the lead researcher of this weird phenomenon, it says that all the fluctuations are real and not due to statistical or instrumental variations. This finding really puzzled astronomers and astrophysicists. The hypotheses range from a swarm of comets orbiting the star, a debris disk surrounding a black hole located between the star and Earth, and finally the aforementioned alien-built megastructure. We can take this one as a last resort hypothesis. But new observations suggest that the real cause is dust, perhaps the remains of a planet the star recently destroyed. It is the most reasonable option as to why the star's light appears to dim and brighten. The new data shows that different colors of light are being blocked at different intensities. We're skipping a lot of details here because actually to get to the conclusion, there was just too much observation that happened. Like nearly a dozen telescopes constantly collected data in almost every wavelength of light. And not to mention that this private project was backed up by more than 1,700 enthusiasts, hobbyists, backyard astronomers, and other citizen observers. The public was psyched for this science, which they could see unfolding firsthand. And up until this point, it's worth asking the question, why do we care about spending billions of dollars searching the nearby stars? Or listening 24/7 for repeating radio waves for signs of Earth-like planets? And all of this just to have at least some evidence that life has evolved somewhere else in the galaxy. So in the next part of the video, we'll explore this premise in detail. Coming up next, right after this. As we gaze into the clear night sky, we all wonder the same age-old question. Philosophers have been asking this question for thousands of years. Yet we are the first generation who have the tools and the knowledge to answer this question with scientific observations. In one way or another, each new planetary system that we discover teaches us a little bit more about how the universe works, and how the Earth, the Sun, and the solar system fit into the whole. In general, we can conclude two main motivations why we want to discover and observe exoplanets within the Goldilocks zone of a planetary system. Number one, finding life viability. There's a lot of speculation that our future lies on another planet, not on Earth. Even Professor Michio Kaku dedicated an entire book, The Future of Humanity, talking about this concept. When we are looking for life viability, we are looking to find planets that humankind can occupy in the future. When we look back in history, about 99% of all life forms have gone extinct. Sooner or later, humankind will be going through this extinction cycle as well. And the forecast that when the sun is turning to a red giant and swallow Earth in a few billion years, all living beings on Earth will have to deal with the consequences. So when looking at the bigger picture, considering all the probable future threats to mankind, preparing for some kind of relocation plan is our final frontier. Number two, understanding the phenomenon of life. What finding exoplanets do for us is to open up a vast exploration area to look for other habitable worlds. If we could find life in those worlds, there are a few questions we can ask, like, will they be a carbon-based life form, or will they be based on something completely different? If, for example, we found that life on another planet had DNA, just like all living things here on Earth, then we could sequence that DNA of that life form and see if it shares chromosomes with life on Earth. So in a nutshell, learning about how life is different on other planets would tell us an immense amount about how life on Earth came to be. Because of these two main reasons, we found ourselves right at a crossroads in the search for life. On April 4th, 2001, an astronomer from Geneva University announced the discovery of a planet, HD 28185b. The planet, which is nearly 6 times as massive as Jupiter, is the first to be found in the Goldilocks zone of its planetary system, where life could possibly exist. But to give you a little bit of the nuance, there are just too many trivial factors that needed to occur, and getting the right combination is extremely hard. For example, if you want to calculate the average temperature that some exoplanet has, given its distance from its host star, you'd need to know a lot about that exoplanet, like the kind of atmosphere it has, the albedo factor, and whether it has any kind of greenhouse effect. There is even an entire chapter just talking about temperature of the planet as one of the factors. The troubling thing is that sometimes scientists don't know those factors, so calculations can give wrong answers. Take for example Venus. Using the previously shown equations, if we calculate the mean surface temperature of Venus, then we'd expect quite an extreme margin of error when comparing the value to the actual surface temperature. This brings us to, out of all the 4,000 hitting records of exoplanets found so far, maybe not even 10% qualify to be habitable. And out of that 10%, who knows if we could ever find the 1% outlier, where that exoplanet contains any remnants of life, let alone the odds that intelligent civilization would arise from that life. Many people would find it disheartening to learn that after all, we're entirely alone in this vast universe. On the other hand, our planet, from the earliest times, was just like any other, winning a lottery ticket in the Olympics of Cosmos, while cheering for the cult of life and intelligent life. Venus, Mars, and perhaps any other exoplanets in the universe had their chance as well. But only in our world did life sustain and thrive, and eventually give rise to an intelligent and technologically advanced civilization. Perhaps for now, our planet is all that matters. Earth and its perfect position in the Goldilocks zone of the Sun. But humans, as curious living beings, continue to find out what lies beyond our space. This same pioneering spirit is what caused us to spread out and colonize our entire planet. All of the technology, science, and mathematics are just the consequence of that same drive. Therefore, space, because we are human. If this video has been helpful in any way, don't forget to give it a thumbs up and subscribe to the channel. And